Hello, this is Mr. Holly. We're going to be looking at lesson 2 on proportional relationships. And this should be pretty much your first experience with proportional relationships. So we're going to go kind of slow. And I'm just going to kind of introduce you to what we're going to be looking at. I'd like to start with example 2 instead of example 1. So if you'll be looking at your notebook at example 2, I would like us to look here at the proportional relationship between cups and ounces. You say, well, what is a proportional relationship? Well, as we begin to look through this unit, we're going to start to look at basically two things changing at the same time. Two things that will be varying, or two things that we will label with variables, and they will be changing at the same time. In this case, we're looking at cups and ounces. Cups are increasing. The number of ounces is increasing in our double number line here. So we have to ask ourselves, is it proportional? And what I mean by that is, do they increase at the same rate? Is there some rate at which they are increasing? So as we look, in order to do that, we would look at this and we would say, okay, so is there some multiplier that connects my number of cups to my number of ounces? Like, what do I have to do to go from 1 cup to 8 ounces? What is the relationship there? And we would see that that's times 8. If I look over here at 2, what is the relationship between 2 and 16? That's times 8. So I can see that I'm multiplying my cups times 8 to get ounces. Is that true for the other ones? Well, let's test. What is 1/2 times 8? That's going to be 4. That's right. And 1.5 times 8. Well, 8 times 1 is 8. 8 times 1/2 is 4. So 8 and 4 make 12. Yes. Times 8. These are all multiplied by 8. What about 0 cups? What if I had 0 cups and I multiplied it by 8? Yeah, 0 times 8 is 0. So, yeah, it would be, these are all being multiplied by a factor of 8. So, the ounces, we would say, are proportional to the cups. Now, as we explore this, this is just kind of the first layer. We can peel back some other layers. As we do this, we're going to start to label some of these variables, or some of these different units, or whatever we're talking about. We're going to label them with variables. And in this case, we might label cups with the variable x and ounces with the variable y. And we would be able to test to see if this is a proportional relationship by looking to see if, when I multiply my constant, which we found here to be 8, this is a key vocabulary term, constant, which we're going to always label with we're going to use k to describe constant. If I take my constant 8 and I multiply whatever I've picked as my x variable by 8, do I get y? So for instance, in this case, if cups are x, if I do 8 times, let's use 1/2, 8 times 1/2, do I get 4? The answer is yes. Try another one. If I do 8 times 2, do I get 16? And yes, that works. So this is going to be the relationship that we create in a proportional, when we have a proportional relationship. That there is some constant, we'll call it k, but it's actually going to have a value. We're going to have some constant value here, and it's going to be, when I multiply my x times that constant, I'm going to get my y. Or when I multiply my first variable by this number, I'm going to get my second variable. And that's the relationship, and it creates this nice equation that we're going to use and develop for the whole unit. So this is the relationship that we're looking for. Is there a constant multiplier between x and y? and we can see in this relationship, this equation, we can see that relationship, okay? So let's come up here, let's look back at example 1. Example 1's the same idea. It's just a little harder to see because it's not, the math is not as neat, okay? So, a new self-serve yogurt store opened this summer that sells its yogurt at a price based on the total weight. Each member of Isabel's family weighed their dish, and this is what they found. Determine if the cost is proportional to the weight. So this would be like if you've ever been to any of the yogurt stores, like a Sweet Frog or a Sweet CC's or Sweet Spoon that was in the mall, or any of those type of yogurt stores where you go get the frozen yogurt, you put the toppings on, and then they weigh it, and they charge you based on the weight. That's what's going on here, okay? Now, they want to know, is this proportional? Like, is it based on, do they charge them some rate times the weight? So we would say, is there a relationship between X, the weight, and Y, the cost? So is there some number that we can get that would make this equation, Y is going to be equal to some number times X, K times X? Well, let's see. 12.5 and 5, that's not particularly easy from a multiplying standpoint, but this is pretty easy. What would I need to do to multiply 10 by in order to get 4? 10 times what equals 4? Well, if I multiply 10 times 4/10, these cancel, and then I'm left with 4. So 10 times 4/10, that works. How about going from 5 to 2? Well, if I multiply by 2/5, 5 times 2/5, the 5's cancel, and I'm left with 2. So 4/10, that's literally 4/10. If we're talking about money, that's 40 cents. 2/5, if that was a decimal, that would also be 4/10 or 40 hundredths. So it looks like we're multiplying the ounces, the weight, by 40 cents. Let's see if that works over here. What's 8 times 40 cents? Well, 8 times 4 is 32. And then because of the decimal position here, we get $3.20. 32, $3.20. That works. So it looks like we're multiplying all of these by 40 cents. And that works here as well. 12.5 times 4 would be 50. But because of the decimal, we're going to move that back. We get 5. Okay. So we see that each of these is being multiplied by 40 cents. So the idea here is that I could take whatever my X value is, whether that's 12 ounces, 10 ounces, 5 ounces, 8 ounces, and if I multiply that times 40 cents, I get my cost. That's the relationship that we've determined, and that's the equation for what it would look like. The cost is proportional to the weight. All right, I do want to show you one other relationship here. As you look at the relationship between Y and X, you will be able to determine that there's some constant. But another thing that you guys will pick up very easily, or should kind of intuitively see here, is that there's also the opportunity to look at it this way. Like if this was for every 10 cost 4, every 5 cost 2, well, that's just times 1/2, right? Like this is called scaling, and whenever we have a proportional relationship, it should scale by the same multiplier as well. So even if we went down here at the bottom, 1, this is going to be times 2, would give me 2. 8 times 2 gives me 16. So the idea here that we could also look at this proportional relationship and see that it scales up by the same multiples. So as X increases by a multiple of 2 or 3, Y is going to increase by a multiple of 2 or 3, whatever those variables represent. In this case, it's weight. So as weight goes down by 1/2, cost goes down by 1/2. As the number of cups increases times 2, the number of ounces increases times 2. So we are able to take proportional relationships, and you should also see this multiplicative relationship scaling up and down as you multiply the variables you're going to get. They're going to increase and decrease at the same multiplier, by the same rate or the same factor. Okay, let's look here at exercise 1. During Jose's physical education class, students visited activity stations. Next to each station was a chart depicting how many calories on average would be burned by completing the activity. All right, so our first question is the number of calories burned proportional to the time? Well, let's look. Is there a multiplier here? Times 11. 2 times 11 is 22. 3 times 11 is 33. And 4 times 11 is 44. So that works. Yeah, it looks like, yes, they are proportional. And I would say because the time multiplied by a constant of 11 always equals the calories burned. And if I were to call this X and Y, I could say Y is equal to 11X. This is time. This is calories. If I take my time and I multiply it by 11, I will get my number of calories every time. So now we have a question. If Jose jumped rope for 6.5 minutes, how many calories would he expect to burn? So let's do this 2 ways. I remember I showed you scaling. So if this increases, that's 1. So if I multiply by 6.5, I'm going to get 6.5 minutes. Now I can multiply this by 6.5, and I would get 6 times 11 is 66, and a half of 11 is 5.5. So 66 and 5.5 is going to be 71.5 calories. Okay, so I can say 71.5 calories. Now the other way I would think about doing it is Y is equal to 11 times 6.5, right? Because this is, we said that time is our X. So if I multiply time times 11, our constant of calories burned per minute, I'm going to get 71. And this reminds me to kind of connect this back to something you talked about in 6th grade. In 6th grade, you should have had something, when I look at this and say calories burned per minute, that should really remind you heavily of something that you talked about in 6th grade. And that is a unit rate, right? 11 calories per minute. So if we look through here, you could take any of these relationships, 33 calories in 3 minutes, 44 calories in 4 minutes, and you could calculate a unit rate of 11 calories per minute. The concept of proportional relationships is that we're taking that unit rate and then we're extrapolating it or seeing how it plays out over as we increase both of those variables, as we make them larger and smaller. We're looking to see how does that unit rate work as a constant rate as we continue to stretch that out. All right, here's our last example. Alex spent the summer helping out at his family business. He was hoping to earn enough money to buy a $220 gaming system at the end of the summer. Halfway through the summer, after working for 4 weeks, he had earned $112. If he continues to work and earn money at this rate, so we have a proportional constant rate, will I have enough money to buy the gaming system at the end of the summer? So let's look. Here is his rate. He's earning, every week he earns $28. So I would say $28 per 1 week, right? So I could make this relationship Y equals 28X, and I could plug in my number of weeks and find my total earnings. So 2